Okay, here we go. Here's lesson 5.4, solving radical equations and inequalities. The name of the lesson in the book. We'll really just work with the equations, solving equations. I think a good lesson in the sense that we're just building on a lot of our traditional equation solving skills. So I think most people find it pretty doable. But there's still a few things that we got to make sure we're watching out for and taking care of. So follow along with me. This will be the portion of the notes that we're doing like in our notebook, so it's probably not a bad idea to kind of follow along with me and just do them as we normally would. Have your notebook in front of you, watch the video, get the examples set up, versus just watching. You know, I would say just watching the video or watching me and listening in class is better than not, but you're not taking a whole lot out of it other than just listening. So I know you can go back and rewatch these and stuff, but it's probably a good idea to have these kind of worked out in your notes so you can do them side by side with the homework, okay? So really the only kind of note other than example that we're going to look at here is extraneous solutions. And I don't know if that's not necessarily worth writing down. I think we can just kind of talk about it here. But extraneous solutions are ones that we solve an equation, we get an answer, it looks like an answer. I didn't break any rules, I feel good about my answer. But when I actually go plug it back into the equation and check, I don't get a true equation. So unfortunately, that's a downfall of this lesson, is we're probably going to have to check most of our answers. And not super formally, but we do have to check to make sure they're not what we would call extraneous or like a fake answer almost, okay? So really all we want to do is go through a couple different examples. I'll try to go quick, keep the video short, but make sure that we can see a bunch of the different types of stuff we're going to see, okay? All right, here we go. So example one. Solve the directions are the same for every single one. Solve the equation, check for extraneous solutions. So first one, I'm looking at, so we're solving stuff involving square roots. So there's a square root going on here. At some point, we're going to want to square both sides, but not yet. We always want to make sure we get rid of anything that's going on that's with the square root or cube root, are pretty much what we're going to see here today. So just traditionally, how would you get rid of a times 2? You divide both sides by 2. Now we still have the x plus 1 equal to 2. Here's the spot. Now we're ready to roll. Square both sides. Okay, and the I'm keeping the number small here just to make it easy. Left side, all we're doing is really getting rid of the square root. Right side, we're talking 4. And then we end up with a pretty nice finish. Show your work, show your steps. X equals 3. So again, I like my answer. I think I feel good about it. We didn't make any mistakes. I do have to check though. So here's what I mean by checking. I want to see at least a little bit of your check on your homework. I'm not saying you have to do the whole thing, but as I'm going in to plug this back in, 3 plus 1 is 4. So you can even get to this spot right here. You know, not necessarily showing every single step. Equal to 4. So just making sure that this left side comes out to 4. The square root of 4 is 2. 2 times 2 is 4. Yeah, it checks out. I like our answer. It's good. We don't have to modify it. X equals 3 is good. Okay. Next one. Similar. Not a whole lot. Actually, not a whole lot different. The last one we saw, getting rid of a 2 out front times, we would divide by 2. In this case, just pay attention to this minus 1. It's not underneath the cube root. It's outside of it. So this is something that we would have to get rid of right away before we take the both sides to the third power. Okay, so it's kind of a nice fix. Again, I'm keeping the numbers small enough here. We still have, don't lose track and don't just get rid of this right away. Sometimes people make that mistake and you say, all right, I got rid of that and that at the same time. It's still there. Now we're talking 3 on the right side. Okay, now everything's gone. There's nothing being added after, nothing being multiplied up front. Let's take both sides, in this case, to the third power because it's a cube root. Okay, so left side, just like we saw in the last one, we're going to end up with just, let's see if we can get this here, 2x minus 9. 3 times 3 times 3, or 3 to the third power, is 27. And we're left with, I don't know, I think a very doable equation, right? Just old school, middle school solving, plus 9, 2x equals 36. We'll divide both sides by 2 here to get x equals 18. Going back, just a quick check. Do it all. Do this all under the radical. That's fine. What is the cube root of, let's see, 18 is going in. 18 times 2 is 36. 36 minus 9 is 27. So we're kind of just reversing it. These first couple checks aren't bad. You're kind of just reversing the process that you just went through, basically. The cube root of 27 is 3. 3 minus 1. Sure, it's going to check out. 2 equals 2. I like it. I think our answer is good. Don't have to change anything. We will get to some that are extraneous, so I'm going through and checking them just like you should be doing too. All right, changing it up here a little bit. Now we're no more roots, no more square roots, cube roots. This is more, now we've got to a rational exponent, which is still, we should hopefully know that this part right here could be written, well, let's get rid of the 2 first. We'll go back to the read-write portion of it here in a second, but anything that we can get rid of and combine, let's do. So I end up with, on the left side, 2x to the 3/4 power. This whole thing's being taken to the 3/4, so don't lose track of it, and then equal to 8. So we should know from previous lessons that this right here is the same thing as the 4th root of 2x to the 3rd power. And you could solve it by doing this. What would we do then? You know, I'd have to take the cube root of both sides to get rid of the cube, and then take both sides to the 4th power. So I can do that here in 2 steps. I'm going to show it here as a little bit, actually just a 1 step, maybe make it a little bit easier on us. We can, as long as this is by itself, I can take both sides to a power to get rid of this. Why 4/3? Well, the reciprocal, remember the property that says we should be multiplying these exponents, so 4 times 3 is 12, 4 times 3 is 12. We get 2x to the 12/12, or 1. So that's essentially how we're going to get rid of those exponents there. And then we have 8 to the 4/3 on this side. Now we have to do that. We have to evaluate that, which I've got my calculator here. We can go 8 to the 4/3 power. Awesome. 16. And then just like the last couple, we finished with something that's very, very doable. X equals 8. Let's take a quick check. 2 times 8 is 16, so basically 16 to the 3/4 power plus 2. We should hopefully be getting 10. So just a quick check on the calculator. 16 to the 3/4 is 8. 8 plus 2 is definitely 10. 10 equals 10. I think we're all right. So far, so good. Moving on. Similar. Okay, we got a little bit going on inside now the parentheses. So let's take a look here. Right off the bat, I'm ready to roll. I cannot drop this in here like this. Do not do that. Get rid of the exponent by taking both sides, the whole side, in this case to the reciprocal, which would be the 3/2 power. So we get this kind of cancellation going on here. 3x plus 4 is my new left side. 16 to the 3/2 power, checking it out, I get 64. All right, great. 2-step solve. Subtract 4 from both sides. Divide by 3. You get x equals 20. Quick check. 20 times 3 is 60. 60 plus 4 is 64. So we're basically just going to quick check. Does 64 to the 2/3 power equal 16? 64 to the 2/3 power. Yep, I'm getting 16 equals 16. I like it. I think we're good. All right. Moving up, we get kind of progressively harder here. These so far, hopefully nothing's been too bad. I think this next one still kind of falls into that, all right, this is pretty easy. I hope is the case. I guess I don't want to assume that they're all going to be easy, but hopefully this one kind of falls into that category. A little bit different, now we've got square roots on both sides, okay, but it actually ends up being, maybe out of all the ones, probably the simplest, because how would you get rid of this square root? You'd square that side. How am I going to get rid of this square root? I'd square the side. So as long as I'm squaring both sides, I'm not breaking rules. That's something we can do to solve an equation. So left side, you're left with 2x plus 5. Right side, again, you're just getting rid of the radical, x plus 7, and you're left with just a linear, what looks to be linear equation. It is. Minus x from both sides. And then subtract your 5 to get x equals 2. Quick check, just making sure that you get the same thing underneath the radical. So 2 times 2 is 4, 4 plus 5 is 9. So left side, I'm getting square root of 9. Go right side, 2 plus 7 is 9. Square root of 9. That's fine, right? We got the same thing. 3 equals 3, or square root of 9 equals square root of 9. I know you're going to see in the homework, so I just don't want you freaking out when you see it. This exact same problem written like this. Not numbers-wise, but what if we saw this? The square root of 2x plus 5 minus the square root of x plus 7 equals 0. For some reason, everyone sees this and they say, oh, I don't know. I don't know what to do for this one. Do I square both sides? And before I do all that stuff, I can make this right here look just like this by adding this whole thing to both sides. And then we're right back to where we started. Okay, so if you see one where we're both on the same side like this, don't freak out. Just add it to both sides, get it over here, and then you're right where we started this problem. All right, stay with me. We got 2 more to go. These next 2 are legit as far as difficulty level, and we're going to review some stuff here that we haven't done in a while. So let's take a look. All right. It looks kind of like the one we did 2 before. If I were to clear all this stuff out of here, it looks kind of like this one. Just in that we've got a grouping taken to a power equal to 16, a grouping taken to a power. The big difference is not a number over here anymore. It's x. Okay. So our process is going to stay the same as far as like initially just getting going. Hey, I don't have anything to get rid of here. I'm ready to roll, and let's square this side. The thing is, when I go to square this side, it doesn't evaluate to a number. It's just x squared. So left side, we're sticking with the x plus 30. These canceled. Right side, though, is x squared. Uh-oh. No idea how to solve this. Should I square root both sides again? No, it's kind of just going to get rid of this, put this back under a radical, and we're in a circle that we can't get out of. So I need a better way to solve this. How do we solve a quadratic equation? Oh no, it's been too long. Bring everything over to one side. Okay, so we're talking 0 now over here, right? That should look familiar. We want to be equal to 0 minus x minus 30. Uh-oh. Here we go. I need 2 numbers that multiply to negative 30 that add up to negative 1, right? This negative 1 right here. Not too bad, right? Negative 6 times 5, negative 6 plus 5, yep, negative 1, negative 30. So it checks out. X minus 6, x plus 5 equal to 0. So we end up with, let's scroll down here a little bit. Whoops. X equals 6 and negative 5. Now here for sure, this is our first one that we're seeing with 2 solutions. Not a dead giveaway, but probably a pretty good chance that one of these are going to be extraneous. Okay? Not always the negative, but a lot of times it is. They could both be true solutions. They could both be extraneous, though. So it's worth checking both. They're not, again, the check isn't overly in depth here. So I'm basically, let's check the 6 first. I'm hoping this one works. One of these should, I think, work. Plug it in here. X plus 30 is 36. So I'm basically looking at 36 to the 1/2 power. Does that equal? And I got to get the 6 in over here as well. So 36 to the 1/2, that's essentially the square root of 36. Yep, 6 equals 6. So I like that answer. I think we're good there. It's the negative 5 I think we're having an issue with. It's close. They're usually going to be the same number, just opposite signs. So if I plug in a -5 here, I get -5 plus 30 is 25 to the 1/2 power. Okay, we can do that. But it's this right side now that we end up with a -5. 25 to the 1/2 is the square root of 25, which is 5, which is not equal to -5. So I want to make sure that in my final answer that I take this off or like identify this as extraneous. Okay, so with 2, again, it's not always a dead giveaway that it's extraneous, but chances are one of them will likely be extraneous. All right, last one. Similar idea. We've got kind of X's on both sides here. The issue with this one is going to be, it's the last one. It's going to be the toughest one. We're actually in a position where we can square. I've only got the square root on both sides. Where it's different than this one was we squared both sides. Sweet, it got rid of the square roots. No problem. Easy solve. Maybe the easiest one yet. Here, when there's not a square root over here, when I go to square both sides, the right side's all well and good. Whoops, let's square both sides. I just get my 7x plus 15. Great. But now over here, do not drop this in here, squared and 1. This is old school, x plus 1. X plus 1. Oh no. Darn it. We got to FOIL this. Okay, so left side, x times x. X squared, so I'm going here. I'm getting a 1x. I'm getting another 1x. So I'm just going to go right ahead and write that as 2x. And then my last one is 1 times 1, which is 1. And we're equal to 7x plus 15. So we're going to have to finish this one kind of like the last one in that we've got this squared here. Our only way of solving these quadratics, we've spent multiple chapters doing this, is getting everything together on one side. Okay, so in a case like this, I'm going to subtract a 7x and a 15. I'll just do it in a single step here and hopefully not screw it up. Get it all over on a single side. So what are we talking here? X squared, 2x minus 7x is negative 5x. 1 minus 15 is negative 14, and we're equal to 0. So we end up kind of in that same position we just were, where I'm looking for 2 numbers. If I'm going to try to factor this, you could quadratic formula this, but that's a lot of work for them. Usually they're going to factor, at least in this lesson. If I'm giving you something that's factored, or that quadratic, it's probably going to factor, okay? So I'm looking for 2 numbers that multiply to negative 14, that add up to negative 5. And I think they jump out at us, right? I mean, hopefully, negative 7 and 2, yep, negative 7 plus 2, they both check out there. So we're going to x minus 7. X plus 2 as my 2 factors equal to 0, and then finishing it as x equals 7 and negative 2. So we're in that same position that we just were, in that I've got 2 solutions. Likely one of these are going to be extraneous, but we got to check. So 7 and negative 2 we're checking out. Go back to the original, maybe get some of this other stuff out of here so you don't confuse yourself like I'm going to do. All right, so left side, let's go. We've got, let's start with the 7. 7 plus 1 is 8. Okay, what happens when I plug in a 7 over here? I got 7 times 7, which is 49, plus 15 is 64. So the square root of 64 is 8. We check out, I like 7. This negative 2, as it goes in left side, negative 2 plus 1 is negative 1. Let's see, I'm guessing this is going to come out to 1. It's going to be close. We always said it's going to be close. So negative 2 going in here is negative 14. Negative 14 plus 15 is 1. So the square root of 1 is 1, which makes these not equal, which makes this extraneous. So whatever you need to do, make sure your reader, me, knows that, yeah, we don't want to include that. The only actual answer here is 7. Okay? A lot of times just by squaring both sides of an equation, you potentially set up that that extraneous solution. So I still want you checking them all. They even some of these earlier ones we didn't see any because I wanted to make sure we got solutions for them. But it is possible for these to have extraneous solutions as well. Okay, so there's the lesson. Go back and rewatch any specific examples that that are tougher. Okay, the homework is the worksheet here. I'm going to attach it to the lesson. It's going through all a bunch of different problems like that. It's pretty much just those same type of ones. I put one word problem on there. I'll help you out getting it set up. What is the diameter? So you're going to be looking for diameter that is 3 inches long. So essentially we're plugging in a 3 and solving for D. You guys can do that. All right, so there's the lesson. About 20 minutes. Make sure you get the video watched. Let me know if there's specific questions, you're having issues getting the video, and I will do my best to help you out. All right?